Good afternoon, dear viewers. Good afternoon to those watching us online. Today in our studio, we continue our discussion on the peculiarities of American space exploration related to the Apollo program. But first, I would like to take a historical detour to the year 1959. At that time, in Moscow, in Sokolniki Park, on July 24, 1959, the American National Exhibition opened. The Americans had organized everything beautifully. In Sokolniki Park, they built a new showroom, invited a fashionable architect of the time, and brought with them an entire team that accompanied the well-designed exhibition. You can see the American ladies in uniform. At the time, the American exhibition amazed Soviet women. For example, hairdryers were presented there, which had already become popular in the US but were unavailable in the USSR. Soviet men were impressed by the innovations of the American auto industry. A whole display of some sculptures was set up in the park. It was then that U.S. Vice President Nixon, who led the delegation, famously surprised Nikita Khrushchev with the popular drink Pepsi Cola. You can now see a photo where Khrushchev, along with his entourage, including Clement Voroshilov, is trying this very beverage. The very next day, satirical poems by Sergei Mikhalkov appeared. Caricatures and parodies were published, but people enjoyed drinking Pepsi Cola with great enthusiasm. That was also when the famous kitchen debate took place. The kitchen was part of the exhibition's display of household appliances and featured a washing machine. Many different kinds of discussions were held. Here's the famous photo where the vice president, in the American cultural manner of communication, is pointing a finger at Nikita Khrushchev. Just look at their expressions. To be fair, the American press quickly picked up on the event, and on the cover of Time magazine on August 3, 1959, they featured an illustration of Nixon in Moscow at the Sokolniki exhibition in that same American showroom. This very image later became the main poster of Nixon's election campaign. Why am I telling you all this? Because just a few years later, the second most important figure in the Soviet government, Premier Kosygin, visited the United States in 1967. In the town of Glassboro, located between Washington and New York, he was hosted by Lyndon Johnson, who was then President of the United States. Officially, the Soviet delegation was there to attend a UN session, with headquarters in New York, so a midpoint city was chosen. There, they held discussions. Why is this relevant? Because among the topics discussed during that visit, besides military ones, were also space-related issues, including the creation of the Club of Rome. So, these key figures, including Kosygin, and this will be important later, were already discussing future historical developments. After that, in the part related to the topic of our conversation, came the Apollo missions, 11, 12, and the infamous Apollo 13. It's important to note that a bit later, in 1970, specifically on September 2nd, just 4 days before the famous Murmansk incident which we've analyzed here, suddenly, Apollo 18 and Apollo 19 were cancelled. However, Apollo 16 and Apollo 17 remained in the program and had to be completed. And so, from April 16 to 27, 1972, Apollo 16 allegedly made its voyage. I emphasize, This was in late April 1972. Just 1 month later, on May 24, 1972, in Moscow, during the visit of a high-level United States delegation led by the President of the United States himself, the famous agreement between the USSR and the USA was signed. Agreement concerning cooperation in the exploration and use of outer space for peaceful purposes. This agreement, which you can now see on the slide, provided for the famous joint Apollo-Soyuz mission to be carried out during 1975. It's worth noting that this agreement was based on 3 active documents at the time. They are as follows. The first is the agreement between the United States of America and the Union of Soviet Socialist Republics on exchanges and cooperation in scientific, technical, educational, cultural and other fields. The official title of the second document is Final Document on the Results of Discussions on Space Cooperation between the USSR Academy of Sciences and NASA, dated January 21, 1971. And the third document, also relatively fresh at the time, was titled Final Document of the Meeting between Representatives of the USSR Academy of Sciences and NASA on the Development of Joint Rendezvous and Docking Systems for Manned Spacecraft and Stations of the USSR and the USA, dated April 6, 1972. 3 weeks later, the U.S. President received the entire crew of the so-called Apollo 16 mission at the White House, along with the head of NASA. Interestingly, the highlight of the event was not the crew telling the President and the American people about what they had supposedly seen on the moon, but rather a detailed presentation of the upcoming Apollo-Soyuz mission for those watching the televised report. They referred to it as the Apollo-Soyuz Test Project, ASTP. You can now see model spacecraft in the President's hands, as the American astronauts and the NASA head discussed the features of the future flight. Then, at the end of 1972, came the supposed Apollo 17 mission. After that, all Apollo missions were discontinued. For the next year and a half, there was essentially silence on the topic. Then, on July 1st, Time magazine published a major article drawing attention back to the two countries' leaders. Here is the cover. The two leaders are discussing the arms race while keeping their arsenals behind their backs. The article also mentioned other topics, including space. Notice the lower right corner of the cover. A popular topic among American readers at the time, new string bikini styles. This gives you an idea of the level of entertainment in American society at the time. A month later, on August 9, 1974, came the famous resignation of the U.S. President. So those who had been deeply involved in the matter left the scene. Then, just 3 months later, on November 23, 1974, in Vladivostok, the leaders of the two countries met again. The U.S. President and the head of the Soviet Union, Brezhnev. On the U.S. side, it was President Ford, who had been sworn in. Notably, he wasn't elected. He assumed office by taking the oath as vice president. But even that position wasn't the result of an election. In the 1973 election, Nixon ran with a different VP, who resigned in December 1973. Ford was essentially appointed on Nixon's recommendation. The local legislative body voted him in as vice president, and he then inherited the presidency. Why is this important? Because, as vice president, Ford was formally responsible for overseeing NASA. Within those duties, he was certainly informed about the details of the previously signed space cooperation agreement. Following this, on July 15, 1975, the famous launches took place, along with everything else associated with the mission. Later, an exhibition opened in Moscow. You may recall the 1959 exhibition and how impressively the Americans presented it. The U.S. Vice President also attended. Now, however, this was a landmark event that had been years in the making. The exhibition featured achievements of Soviet space exploration, including full-scale spacecraft models. You can now see the entire system on display at the exhibition, including the docking module. Take note of the central object under covers. That's the docking adapter. Here is a photo from another angle, and yet another view of the entire setup. There are many photos and records, including displays of cosmonaut gear, at least from the Soviet part of the experiment. I'd like to draw your attention to the fact that within the same exhibition and in the same building, there was a display dedicated to the docking of Soviet spacecraft. As you can see, there were no covers. And here's how a similar docking model was presented in the United States of America. The same Apollo, the same Soyuz, the docking module, but uncovered. You can clearly see the details. I've compiled these photos especially for our viewers. For some reason, the details weren't shown on our side. The exhibition was expected to mark a historic event that everyone had been preparing for. They were awaiting a large delegation from the United States. It would have been a good opportunity to exchange views on the current agenda and to seal the outcomes of a major event with handshakes from the heads of state. But what happened? No one from the U.S. delegation showed up. On September 23, 1975, Brezhnev met with the mission participants in the Kremlin and famously said what became a catchphrase. "We saw how you were tumbling up there." On October 15, 1975, at the White House, a similar scene played out. Soviet cosmonauts presented a model to the president. Take note that in the model, the details were also covered with shrouds. But that grand, historic moment never happened, neither in the Soviet Union nor in the United States. And there were only 2.5 months left until the Jamaica meeting, where the economic and financial future of the world and the division of global power were essentially decided. Let me again draw attention to Kosygin's position on the question of whether the Americans actually went to the moon. There's an author named Bogdan Chernenko. Based on documents he came across in the course of his work and research, he wrote a book titled The Deal, a historical novel in declassified documents. Here's a paragraph from it. To the question of whether the Americans really went to the moon or deceived everyone, I will answer clearly and in a military fashion, says the author. They did go, because I have a standing, unrevoked order from the chairman of the USSR Council of Ministers, Comrade Alexei Kosygin, to say exactly that, when asked, did they go, and so on. Dismissed. In other words, it was an official directive, they went, and that's the end of the discussion. Hello, Alexander Ivanovich.
Good afternoon.
Alexander Popov, our regular and beloved author. How did everything unfold, considering all the preparations and the significant geopolitical potential of such a meeting?
First of all, I want to thank you for the very interesting introduction. It reminded me of my youth, because back in 1959, there was an American exhibition in Moscow. I remember as a 9th grader sneaking over the fence to get a taste of Pepsi Cola. That happened. And of course, the cars were impressive. Let me add another thought by association. First, you mentioned that in 1967, the active negotiations between Kosygin and Johnson began in Glassboro. That reminded me. There's an official document from the U.S. Embassy in Moscow available online. It's called U.S.-Russian Relations. It covers history from the 18th century to the present. And it includes a line that is of interest to us. January 1967. Recorded as U.S. Embassy. Start of negotiations on the joint Soyuz Apollo flight. At the same time, the Soyuz spacecraft had not flown even once yet. And already there was such political subtext. And maybe one last thing. Roman spoke very interestingly about the signing of the agreement. I have one of the photos where the signing ceremony is clearly visible. On the American side, it is signed by U.S. President Nixon. Although we didn't have the title of president, everyone understood that the General Secretary was the #1 person in the Soviet Union. But on our side, the agreement was signed by Alexei Kosygin. So, what you're describing aligns exactly. I'm not saying that what we'll discuss relates only to Kosygin. No, everyone acted with the support of their colleagues. But it seems Kosygin was the driving force behind this event. The General Secretary stands among the first in a group of high-ranking officials nearby. So, what you said fits very well into this picture. Now the topic is set, Apollo-Soyuz. I pay very close attention to feedback from readers and website visitors on previous meetings. So, thank you all for your comments. Even thanks to the critics, even to detractors, because I know what they're criticizing for. To keep the feedback going, I want to verbally respond to 2 or 3 of the most relevant questions on this topic. And I encourage our readers to write feedback. We read it. So, first, a question from the previous meeting. I talked a lot about the shuttle program. Of course, all of us who lived through that era were deeply impressed by the shuttles, their enormous size, their proclaimed reusability, the fact that we had nothing comparable, and that our Soyuz spacecraft looked like a dwarf next to the shuttle. But then, not suddenly of course, the realization had been forming for a while, we witnessed the shuttles being retired. And retired in a situation where there was nothing to replace them. Readers ask, how come? You say the shuttle program didn't justify itself. Please explain why. Perhaps I didn't justify it clearly enough, so I'll repeat a simple arithmetic calculation. So, the question from the previous meeting, how many missions per year did each shuttle make? Answer. According to NASA's official data, all the shuttles made 135 flights over 30 years. Why am I talking about the shuttles? It was a major American program, and according to many, the only real American space program in which they flew into space on their own spacecraft. So, 135 flights in 30 years. Divide 135 by 30, and you get, don't be surprised, an average of 4.5 missions per year. There were 4 shuttles in service. 2 were lost, and 1 was built to replace them, but no more than 4 shuttles flew at any one time. Divide 4.5 flights per year among 4 shuttles, and you get 1.1. The answer: on average, each of the 4 shuttles flew once a year. Additional information. I'd remind you that the cost of each mission was, by various estimates, from $0.7 to $1.4 billion per mission. That's expensive, even for a rich country like the United States, and they admitted it themselves. They said, the shuttles were unreliable and insanely expensive. Unreliable because 14 people died in shuttle missions. That's the shuttle program in a nutshell. I believe that answers the question. And now I'll respond verbally to one more question. In our previous discussion, Apollo at the Murmansk Pier, I repeated twice the idea that at the pier of the city of Murmansk, in September 1970, a recovered Apollo 13 spacecraft was handed over, intercepted by us. In fact, it wasn't a spacecraft but a sealed container. The specialists authorized to handle it arrived. There are corresponding photographs. In shape, it was an Apollo. What information is available about it? Many readers ask the following question. In fact, I'm quoting a typical comment here. I don't understand what the point was in launching something with a high probability of being intercepted, especially when it wasn't going to the moon but falling nearby in the Atlantic. Wouldn't it have been simpler to just sink it? What I want to say is this. If we don't understand something, it means we don't know everything. We shouldn't jump to the conclusion that just because I don't understand it, it didn't happen. Now, let me remind you. First, in September 1970, only in the United States. This was not reported in the USSR. TASS relayed information that was published in a number of local American outlets, stating that the Soviet Union was in possession of a space capsule launched under the Apollo program. I am speaking now strictly about facts. In 1970, NASA announced that it launched only one capsule into space. That was Apollo 13. Second, TASS reported that this capsule fell from space. Not dropped from a plane with a parachute, not lost from a ship, not surfaced from the depths of the sea, it fell from space. The only Apollo capsule that could have fallen from space at that time was Apollo 13. Next, I talked about how we saw the capsule sitting on the Murmansk Pier. Specialists from our firm in Ryazov came. Back then it was called the RDA of machine manufacturing. I always say this was a highly diversified company that did a lot for national defense. But to all of us, it's best known for making proton rockets, which we have been successfully using for many decades. These specialists, particularly Anatoly Blagov, noted that the capsule had a beacon on it, in simple terms, a blinking light. Installing a beacon clearly indicates that it was a re-entry vehicle. Otherwise, why put a beacon on it? Why did NASA take the risk of having it discovered? First of all, you have to consider American arrogance. They believe they're the smartest, that no one can outwit them. I don't think they seriously considered the possibility of the capsule being intercepted. Nevertheless, the question remains, why? Why not just sink the rocket and be done with it? And I want to pose this question to the readers. Dear readers, let's put our minds to work. The thing is, in telling the story of the Apollo 13 interception, I have deliberately avoided offering any interpretations. I've tried to relay only the facts. I encourage readers to join in the reflection and share their answers to the following questions in their comments, which I read. I'll offer just one hint. The rocket that launched the Apollos was, of course, top secret. In fact, it was even more secret than military missiles, because it held the following secret. I'm not going to the moon. I'm falling into the Atlantic. Second, this rocket had to be exceptionally reliable, meaning it was a highly advanced technical creation. It needed to complete 10 or 11 Apollo launches to the moon without a single failure. I myself, as an engineer who developed various devices, know how this works. You make something, see how it performs, tweak it, and test it again. This rocket was supposed to transmit data about its performance during flight, what is known as telemetry. All launched rockets do this, including military ones. But this rocket could not transmit telemetry data, even if it was so encrypted that no one could decode it, because it would be enough to detect that the signal stops very quickly. From that, one could conclude the rocket isn't flying to the moon, it's sinking into the ocean. So, I ask, what role could this container mounted on the rocket play in this context? The latest comment essentially pushes us toward this topic. If Apollo didn't go into space, how do you explain the 1975 Apollo-Soyuz program? I'm quoting here. Or was it a joint deception? It would be interesting to hear your opinion. And 34 people agreed that they'd also be interested in that opinion. And that wasn't the only comment like it. So, I think the topic is quite relevant. Consequently, our topic, the experimental flight of the Apollo and Soyuz spacecraft in July 1975. The acronym for the official name Apollo-Soyuz Test Project is ASTP, which I'll often use. Part 1 is strictly factual. I emphasize, this is the main part, with the rest serving as supplements. Its topic and conclusion will be, a real joint flight of the two spacecraft was technically impossible. And my task is to justify that. Since this information may be hard to absorb, I want to break the main part into sections. In the first, I'll tell you the official information about the ASTP, information that, for decades, caused no doubts in us. Not in me either. In the second, I'll cover where those doubts eventually came from. In the third, we'll take a look at the docking, not as specialists, but generally, at a newspaper level. That will be enough for us. Docking is the key element of the ASTP. What kind of joint flight could there be if the spacecraft don't dock? We'll take a look at how the docking began and what it looked like in space. And the fourth section, the largest one, is called the untrodden path. Our engineers and cosmonauts did a lot of work to develop a safe docking procedure. But by the time of the ASTP mission, that path had still not been fully covered. I want to point out that even 20 years later, serious accidents occurred during docking, not just one, but several. Official information. The first proposal for the ASTP was formally made by the Americans. This happened in early 1970. Here, I again want to give credit to the host. He explained the background very well. The formal proposal was made in 1970, but the working negotiations took place during the years you've described. The proposal was made in early 1970 through an exchange of letters between NASA Administrator Thomas Paine, seen on the left, and the president of the Soviet Academy of Sciences, Mstislav Keldysh. Finally, in Moscow in May 1972, an agreement was signed, the one you described in detail. Here's a photo of the signing ceremony. On the left, Richard Nixon signs the agreement, and on the right, Alexei Kosygin. Leonid Brezhnev stands nearby but does not sign. Several high-ranking officials from both sides were present. I want to draw attention to the man on the far left, Henry Kissinger, one of the world's key power brokers, who passed away recently. Formally, the agreement covered a broad range of topics, but the main point was the ASTP. I'll refer to it either as the agreement in general or specifically as the ASTP agreement. It had four main points. The first three were technical, and I won't go into them here. The fourth was quite clear. If you go into space, you must be trying to learn something. The fourth point read, to gain experience in carrying out joint missions of Soviet and US spacecraft. Gaining experience in carrying out joint missions, plural. One note, and in light of your introduction, it becomes especially clear. No high-ranking officials came to our celebration. The Americans kept low profile. Note that the ASTP was the first and last event of its kind. It feels like no experience was actually gained, and that no further joint missions were needed. As the saying goes, the Moor has done his duty, the more may go. You've got to know when to fold them. But for now, that's just speculation. Let's get to the facts. Let's continue with the official information. Here is the official flight schedule. On the left, the American astronauts in brown uniforms. On the right, in light green, are our cosmonauts. Alexei Leonov is standing, Valery Kabasov is seated. July 15th, both spacecraft launch. On the 16th, they maneuvered and approached each other. On the 17th, they docked. July 18th, the day of visits, they visited each other. July 19th, undocking. On July 21st, after 6 days in space, the Soviet Soyuz returns. On July 24th, after 9 days, the American Apollo returns. That's the official schedule. Here's a newspaper I've kept for myself, my own photo. The paper has even yellowed with age. It's an issue of Izvestia from that time. I should say that we had two main newspapers, Pravda and Izvestia. Pravda was the organ of the Central Committee of the Communist Party, and Izvestia represented our parliament, the Supreme Soviet at the time. You can see the headline, Soyuz Apollo in red. Back then, red ink was rarely used, reserved for special occasions in the press. Izvestia from July 15th reads, Soyuz Apollo, orbit of cooperation, with kind wishes to the Soviet and American cosmonauts, and so on. All newspapers were filled with this. Radio, television, every media outlet was covering it. On that day, our Soyuz launched from Baikonur. From Cape Canaveral, a rocket officially carrying the Apollo spacecraft lifted off. On July 17th, the docking took place. Here, at the threshold of that tunnel, which they sometimes closed, sometimes opened with a curtain, the so-called historic handshake happened. Our cosmonaut Leonov is lying there, shaking hands with American astronaut Stafford. Below is a newspaper clipping, a computer-generated montage titled, The Historic Handshake. This phrase, the historic handshake, served as the motto for the entire scene. After that, the hatch was closed, the crews went to rest, and the next day was dedicated to mutual visits. Look how great the astronaut is feeling. They had work to do, participated in various ceremonial events, and demonstrated their friendly relations. Look, there's zero gravity. One cosmonaut is upside down, the other is right side up, and everyone is happy and smiling. As our official publication notes, things like that happen in orbit. And yes, it really does look like zero-G. Look how cool it is. In the background, you can see the interior of the Soyuz spacecraft. Live TV reports from Houston showed the joint operations. Major world leaders, the UN Secretary-General, presidents and prime ministers at the time, all sent their congratulations. What doubts could there be when you're seeing it with your own eyes and the world's top leaders are celebrating the success? There were no doubts, for a long time. Then, from the work of a growing number of researchers uncovering the NASA moon hoax, seeds of doubt began to grow. Naturally, questions of various kinds arose about the Apollo spacecraft itself. If there were no moon missions, maybe the spacecraft itself never existed? In our last discussion on February 15th, we talked about a summary topic: 4 reasons not to believe in Apollo. I emphasized then, and I want to say again now, that there are more than 4. I just selected the ones easiest to discuss with a general audience. What were the reasons? I'll briefly repeat them. First, the astronauts supposedly returning from Earth orbit or even from the moon looked far too energetic. At the time, it wasn't widely known, but decades later it came to light that our cosmonauts emerged completely exhausted, even after a 5-day flight. And here he supposedly went to the moon and back in 13 days, and steps out looking like a model. Second, this issue came up recently, in connection with the Space Shuttle program. When the Americans had to shut down the shuttle program, it suddenly became clear they had no means of getting to the International Space Station. And this wasn't a surprise. They had known this was coming, as early as 8 years before, after the Columbia disaster, and had hinted that the shuttle would eventually be phased out. There was time to pull out the Apollo blueprints and refresh the old designs. Swap out the calculator for a modern computer, and so on. Look at our Soyuz. The shell hasn't changed much, but the contents are always evolving. The Americans could have restarted Apollo production. But they didn't. Instead, they relied on our Russian taxi to get to the ISS for 9 years. So maybe there never were any Apollos? Third, both I and Leonid Konovalov, using 2 completely different methods, analyzed launch footage, some of it amateur, and were able to calculate the rocket's ascent speed. People often say, amateur footage isn't reliable. But let me remind you that in 1963, a world-shaking event occurred, the assassination of US President Kennedy. You've probably all heard of it. Well, the key documentary evidence in that case was an amateur film by hobbyist Zapruder. I don't remember his full name. So, if there's no other reliable information, why should we reject what we have? Especially when the amateur footage isn't manipulated, the person simply records what their camera sees. And based on such materials, we determined the rocket's launch speed. Not from the very beginning, but it was possible to determine it at the 106th second of flight. At that moment, according to NASA's official data, the rocket was supposed to be flying at nearly 1 kilometer per second, more precisely, 920 meters per second. But it was actually flying 7 to 8 times slower. A rocket like that won't even reach low Earth orbit, let alone go to the moon, and spacecraft aren't launched on such slow rockets. Now, the fourth factor is the story about the capture of the metal container allegedly being Apollo 13. I've talked enough about it before, so I won't get into that now. As a result, we came to the conclusion that the Apollo spacecraft was a myth of American propaganda. And that brings us back to the previously quoted reader comment, an idea that occurred to us and to many others. If the Apollo spacecraft is a myth, then what was the ASTP mission? The third section is about the docking. This one is short. We're just getting acquainted with it. First, as I already mentioned, docking is a key element of a joint spaceflight. In this illustration, the 2 spacecraft are docked, and through the connecting tunnel, the American astronauts, dressed in brown, are crawling over to visit the Soviet cosmonauts. Without docking, there is no joint flight. Let's take a look at both countries' experience with docking and how it works. According to NASA, the Americans performed about 20 dockings and undockings during their moon missions. Thus, supposedly, it was a piece of cake for them. As they say, a picture is worth 1,000 words. But in NASA's visual materials about these dockings, numerous forgeries have been found. I'll give just 2 examples. Here's a well-known NASA photo. The Apollo lunar module has separated from the main Apollo spacecraft. This supposedly takes place above the moon. The module is about to land. On the right, you see the same image processed with a graphics editor. I'd like to point out that when these images were created, computer graphics didn't exist. We can see, the space background is uneven. We may not be experts in composite photographs or film effects, but we know space is pitch black because it's a vacuum. Nothing reflects in a vacuum, so it appears black. But here we see a non-black background. This is a studio forgery. On that, we can be certain. And it's not a one-off. Here, for example, is a similar lunar module from Apollo 16. On the right is the same image after processing. The image of the lunar module is clearly inserted onto a black background. Another studio fake. I won't go into details about how exactly it was done. There are experts for that. But we're not interested in model dockings filmed in a studio. So, let's move on to the Soviet experience with dockings. This was the only real experience that existed at the time. Here's a diagram of the docking of two Soyuz spacecraft from the newspaper Pravda, dated 1969. By the way, this aligns perfectly with the earlier conclusion. The Apollo spacecraft didn't exist. What kind of docking experience could there be with a non-existent spacecraft? But here, I'm deliberately taking a step back and analyzing the same issue from the docking perspective. Even if Apollo had existed, a joint mission would have been impossible. That's what I will try to prove to you. So, two spacecraft approach each other. Such system is known in mechanics as probe and drogue. The probe finds the drogue, and the drogue adjusts for small misalignments. The probe gently enters the drogue. Of course, the spacecraft must not crash into each other. They have to approach carefully. That's the ideal picture. The docking is complete. Let's look at how it actually happens. But a lot was classified back then. And it was hard to film. How do you film two spacecraft docking from a third one? They tried it once, but that mission failed. It didn't work. So, let's take modern video instead, especially since it will show us the ideal docking method that our engineers, designers, and cosmonauts were striving for back then. This is a clip. I made it from fragments of two Roscosmos videos. I'll explain a bit beforehand, because it's going to be brief. The first part shows the launch into orbit well, and how the spacecraft approaches the ISS. It's convenient to film from the ISS because it's huge. The docking port is somewhere around here. You float up to the window and film. We'll see from that angle too. You'll see the spacecraft approaching and firing bright flashes to the sides. These are attitude control thrusters that control the ship's positioning, forward motion, and braking. In other words, they ensure smooth approach. Let's watch the clip.
Это не тот клип. Ну ладно, пусть будет тот. Тот. Я ошибся.
It's shown well. This is the launch escape system being jettisoned. Now the stages are separating, the famous strap-on boosters. This is computer animation. The spacecraft is revealed. The penultimate stage fires. Final acceleration. Now the spacecraft is flying toward the ISS. There's the ISS. The black dots are the docking ports. And this is cosmonaut Oleg Artemyev filming from a window on the ISS. Look how slow it is. I want to point out that the approaching craft on the left is a 7-ton machine. That's a serious truck. Not every truck weighs that much. And it's approaching at a speed of 10 centimeters per second. You can see the probe heading for the docking socket. You can see the thruster flashes. The bluish glow is Earth's horizon. This is a nighttime docking. Now you'll see the spacecraft make contact with the port and recoil a bit. So, there was an impact, but it was soft enough. The spacecraft bounces back slightly.
What spacecraft is this, Alexander Ivanovich? Please repeat.
One of the Soyuz spacecraft.
One of the Soyuz?
Yes, Soyuz TM, I think.
The program is called Apollo Soyuz. So, the technological foundation is the same.
And the docking procedure has remained essentially the same. No one's come up with anything smarter since. So, the craft approaches. I want to draw attention to the docking speed. The docking process is controlled from the Mission Control Center. Lots and lots of numbers, we won't get into that. We only need one number. It's shown in large font, 9 centimeters per second. It also says 0.09 meters per second on the screen. That's the approach speed. I rounded it to 10 centimeters per second, 9 centimeters per second, so there's no impact. I did a quick comparison. A matchbox is about 5 centimeters long. Not all of us can drive a car with that level of precision when parking. I want to address those here who are more into the humanities, especially when they're driving, and remind them of the traffic police warning. If anything feels off, slow down. Kinetic energy doesn't increase linearly with speed. If you double the speed, the energy doesn't just double. It increases with the square of the speed. So, if you're driving at 60 kilometers per hour and you bump it up to 120, good luck. But in case something goes wrong, your car now carries 4 times the energy. The braking distance, if you manage to stop, will be 4 times longer. And the impact consequences, though hard to calculate, will also be 4 times more severe, because energy scales that way. I rounded the docking speed to 10 centimeters per second. Back in the days I'm going to talk about, the permitted speed was 3 times higher, 30 centimeters per second. That means the collision energy was 9 times greater. Why didn't they go slower? They couldn't. That kind of delicate maneuvering needs refined control systems, especially good computer systems, which they didn't have at the time. And special attention also had to be given to the thrusters. So, the speed factor will be central throughout the rest of my presentation. The beginning was tragic. On April 26, the Soyuz 1 spacecraft was launched, the first manned spacecraft of this class. It was planned that the next day, on April 27, Soyuz 2 would be launched, and the 2 manned spacecraft, Soyuz 1 and Soyuz 2, would dock. But Soyuz 2 remained on the ground because Soyuz 1 encountered very serious problems. An emergency return was ordered, but that too went wrong. During the parachute descent stage, the parachute failed to deploy, and the spacecraft crashed straight into the Kazakh steppe. On the left, we see the remnants of Soyuz 1 still burning, and the portrait of cosmonaut Komarov. What can be said? Honor and glory to the heroes, and may they be remembered with respect. But what lessons were learned? Logical conclusions were drawn. The manned spacecraft had to be refined. This refinement would take a year and a half. To avoid losing time in terms of docking development and methodology, it was decided to assign 2 or 3 dockings to unmanned spacecraft before the next manned flight. Unmanned spacecraft are simpler, they don't require life support systems. We're talking about the so-called Cosmos spacecraft, which were essentially automated Soyuz spacecraft with the life support systems removed. Before moving on with the narrative, I want to characterize the entire 4th section. I've titled it, The Unfinished Journey. If a safe orbital docking is needed, one that ends with the safe return of cosmonauts to Earth, then the initial attempt to storm the docking fortress failed. That was Komarov's flight. They had to move on to a prolonged siege. I've called this the unfinished journey. The siege was not completed. I'll talk about 10 Soviet test manned flights. There will also be unmanned ones. I've called them 10 steps on the path toward a relatively safe orbital docking. The phrase, relatively safe docking, is key. Safety can always be improved, endlessly. But at some point, a rational stopping point is needed. Since we're discussing the topic of an international flight, my approach will be somewhat special. Every flight I'll talk about was an achievement of Soviet space exploration. But if you propose to carry out an international flight, the requirements increase drastically. The approach becomes extremely strict. Because the first joint international mission was not just a scientific or technical event, it was a major political event. It could only happen if it were preceded by several fully successful test flights, each involving a successful docking, undocking, re-entry into the atmosphere, and the safe return of both spacecraft to Earth. Now let's move on to our 10 steps. The first step was taken by unmanned spacecraft. On October 30, 1967, the automated Cosmos 186 and 188 performed the first orbital docking in history. Here, I speak on behalf of all developers. We must highlight the miracle of automation. The docking had to take place outside the radio visibility of all our observation stations. The spacecraft automatically detected each other, automatically approached, and automatically docked. Of course, this was an outstanding achievement. But like with any development, there were significant drawbacks. What problems did the first pair of Cosmos spacecraft encounter? First, and this was revealed later through telemetry analysis, instead of an airtight seal, there was a rigid capture, but with a remaining gap, no leak integrity. For unmanned craft, this doesn't matter, but for manned flights, it's unacceptable. Then came the re-entry. Cosmos 186's attitude control system failed, and it re-entered steeply with a 9 times gravity overload. That's fine for machinery, but for cosmonauts, it would be a serious emergency. When Cosmos 188 began its descent, they switched on a different attitude control system, hoping it wouldn't fail, but it did too. Now the spacecraft descended too shallowly and would have landed who knows where, like in the Pacific Ocean, where no one would be expecting it. Naturally, it would have sunk there. If there had been cosmonauts aboard, they would have gone down with it. The spacecraft was destroyed in flight, still in the stratosphere, as it passed over Irkutsk. Of course, the docking in space was a success, but for a crewed flight, it would have been a dangerous experiment due to the factors I mentioned. The second step was also assigned to the automatics. On April 15, 1968, Cosmos 212 and Cosmos 213 performed the second docking in space, this time a pressurized one. However, there were new failures again, this time with the parachute systems. The parachute release mechanisms failed.
So, the docking and undocking go according to plan, but the re-entry doesn't work out.
Everything happens on the way back. We'll see one case where even the undocking doesn't happen. The return journey is where problems arise. It may seem like nothing, a piece of metal dragged across the steppe. No ravines, no mountain ridges. But if you drag cosmonauts across those bumps after they've flown for 6 to 9 days? That's unacceptable for a joint mission. The third step, I called it an ordinary failure, because failures happen in every new undertaking. Naturally, future successes are built on past failures, once the shortcomings are fixed. After Komarov's flight, this was the first crewed mission. The Soyuz was improved, and cosmonaut Beregovoy went into space on Soyuz 3. Soyuz 2 was uncrewed, and the goal was to dock with it. Beregovoy managed to bring his spacecraft within 40 meters of the uncrewed one. That's very close, but the other spacecraft was misoriented. And there wasn't enough fuel left for the necessary fly around and docking maneuver. The docking had to be called off. But importantly, there were no collisions. Everything was done carefully, and the re-entry was successful. I'll show you many emergencies, many incidents, even one fatality, but starting from Beregovoy's mission, all solo Soyuz flights ended successfully. Problems only arose in missions involving docking. In the table, you'll see that during the 6 years before ASTP, there were 9 solo missions, not a single incident. But the reality of the 1970s when it came to dockings was this. If you're attempting a docking, expect trouble. Or at least be ready for it, or worse. Right up until the ASTP flight, every Soyuz docking mission was accompanied by serious emergencies and one tragedy. This spans 7 years and 11 spacecraft. In the table, I marked with an asterisk the cases where the spacecraft got close. Like Beregovoy getting to within 40 meters. But everything remained safe and they didn't touch. But sometimes, there were very risky attempts at close approach, even before docking. The fourth step, outstanding achievements. I say this with no sarcasm, these really were outstanding. For the first time in orbit, 2 crewed spacecraft docked, Soyuz 4 and Soyuz 5. This happened on January 16, 1969. On the right, there's footage from Soyuz 5 showing Soyuz 4 approaching for docking on a screen. Docking occurred. During this mission, they also accomplished another heroic feat. 2 cosmonauts transferred from one spacecraft to another through outer space. At the time, there was no internal docking tunnel. That was the only way. It wasn't a stunt or a game. It was a rehearsal for an orbital emergency. If one spacecraft malfunctions, another Soyuz docks, the cosmonauts from the damaged ship transfer to the working one, and all return to Earth, cramped but safe. These are the heroes of the first crewed docking. I want to highlight Vladimir Shah-Talev, hero of the first successful crewed docking, and the unlucky one in the next 2. Again, this isn't sarcasm. Docking is difficult. It takes courage, ingenuity, and even some luck. And so, Shah-Talev, who carried out the first successful docking, would be unlucky in the next 2. Vladimir Shah-Talev, Boris Volynov, Alexei Yeliseyev, and Yevgeny Krenov. I've outlined Boris Volynov's portrait in red. Thank God not in black, because his re-entry would be extremely dramatic. The other 3, aboard Soyuz 4, returned safely to Earth. But Boris Volynov had a different fate. To understand what we're talking about, a few words about a nominal Soyuz re-entry. It re-enters the atmosphere at enormous speed, 8 kilometers per second, and this is still in the stratosphere. The sky is still black, but there's already enormous air drag, superheated plasma, extreme temperatures. Re-entry must be done with the heat shield forward. Only a small part of the spacecraft re-enters atmosphere, the descent module.
Current illustration, is this the ideal state?
Yes, this is the ideal state, and quite often spacecraft re-enter exactly like this. If they don't, there'll be trouble. The hatch that cosmonauts use to exit on Earth is oriented backwards and protected by the heat shield. But here's what happened to Volynov on Soyuz 5. Due to a technical emergency, the spacecraft re-entered the atmosphere hatch first. The large cylindrical section, the service module, failed to separate in orbit. Some command didn't go through, something got stuck, and the module didn't detach. As a result, it dragged the descent module backwards, in the wrong orientation. In such a situation, the hatch and the sidewalls are sure to burn through, a hopeless scenario. The following description of the incident has been heavily condensed. Sources are cited. The drama of re-entry in a burning spacecraft. The descent module went hatch first. There was a smell of burning, the rubber seals around the hatch were melting. The heat was unbearable, and the situation seemed hopeless. Volynov kept narrating what was happening into the onboard tape recorder. According to witnesses, women at mission control were reportedly in tears. And then, suddenly, the module tore off, and the descent module reoriented correctly, heat shield first. But by then everything was out of sync, and the schedule was scrambled. Re-entry happened on a steep trajectory with 9g acceleration. The landing was so hard that the roots of Volynov's upper teeth broke. But thank God, he survived. An important and unofficial note. Boris Chertok wrote in his diary, "How do we, Russians, celebrate when something goes well? On January 18, in the office's mess hall, we celebrated the miraculous rescue of Volynov, and it really was miraculous. Would something like this be acceptable on an international flight? I don't think so." The fifth step, an ordinary failure. By the way, this ordinary failure came about from Shah Talev's recommendations. It happens. Based on his experience, he suggested some changes. On October 11 to 13, 3 spacecraft were launched into orbit simultaneously. The goal? 2 would dock, and the third would observe, photograph, and record the process. A postage stamp nicely captured the idea of the mission, but in reality, they didn't get that close. Under the new guidelines, they weren't able to approach closer than 1.5 kilometers. In space, that's a very difficult task. It's not like driving up next to someone on the highway. I won't go into detail, but it's a tough challenge. No closer than 1.5 kilometers, docking was out of the question. It had to be cancelled. Not a single spacecraft even touched another. Essentially, these were solo flights. Can anyone guess how they all returned? Without a hitch. The sixth step. The central figure again is Shah Talev. The drama of Soyuz 10. 5.5 hours trapped at the orbital station with a broken docking mechanism. By now, we should understand what kind of impact it takes to break a docking mechanism. Shah Talev, Yeliseyev, and Rukavishnikov, whom I want to point out as a graduate of my own alma mater, Moscow Engineering Physics Institute. He saved himself and everyone else. There's a link below. On April 23, 1971, Soyuz 10 docked with our first long-term space station, Salute. The story is told by military engineer Lesnikov of the Cosmonaut Training Center, whom I often quote, 20 years of experience at the center and an engineer. Remember how Shah Talev mentioned 30 centimeters per second? No faster. But he decided to go just a bit faster to ensure a secure capture. The impact was so strong that the titanium docking probe, about as thick as an arm, bent and jammed. And once jammed, it was stuck, couldn't move in either direction. Shah Talev himself tells the story. I'll occasionally add what I remember. The spacecraft was swaying heavily relative to the station, and we feared the entire assembly might break apart. We couldn't undock. Fortunately, Rukavishnikov managed to find a solution, and we had enough fuel for re-entry. Seventh step. June 30, 1971. The Soyuz 11 tragedy. You could say they were following the path of Soyuz 10. This was Dobrovolsky, Volkov, and Patsayev. On June 6, Soyuz 11 docked with Salute. The docking seemed to go smoothly. They transferred to the station and worked there for 24 days. Then they returned to the spacecraft and began their descent back to Earth. Everything was going fine. Then suddenly, the cabin depressurized. One of the valves, one that was never supposed to open on its own, and that could only be opened manually by the cosmonauts, somehow opened. The cabin lost pressure, the air escaped, and all 3 cosmonauts perished. After that, all crewed missions were suspended for 2 to 3 years.
Was this 9 months before the agreement was signed?
Exactly right. Solo missions had already been halted 9 months earlier. And docking missions wouldn't resume for another 3 years. A sad detail. Their bodies were laid out and covered in white sheets. Thank you for reminding me. This is a fitting moment to bring it up. Look, the 7th step. Tragedy, 1971. No more missions took place after that. A year later, in May 1972, the agreement was signed. So, it's the perfect time to sum up the intermediate results.
Wait a second, Alexander Ivanovich. At the beginning, you mentioned a certain historic document from the U.S. Embassy dated January 1972. That would be 6 months after this event.
No, that historic document is from 1967. It says that preliminary talks began in January 1967.
Got it, scratch that.
Now's the time. The agreement signing is just around the corner. The 2 sides will sign it ceremoniously. But what did they actually have to show for it by then? Let's pull together what we've learned in an interim summary. By the time the agreement was signed in May 1972, there had been 2 crewed dockings. Were the dockings successful? Yes, but the missions were not. And we don't need an international flight with a successful docking but an unsuccessful ending. Flights with successful dockings resulted in 2 dramatic outcomes, one with the drama of Soyuz 5's burning capsule, and the other with the tragedy of Soyuz 11. So, what do we have? One cosmonaut barely escaped being burned alive and broke his teeth upon landing. 3 bodies in the STEP, and docking flights suspended for 3 years. Personally, I see no objective grounds for signing a joint international flight agreement. It just doesn't add up. We already know the agreement was signed in 1972, and since then, there hadn't been a single docking mission. Then comes July 1974. It's been 3 years since the Soyuz 11 tragedy. And now there's only 1 year left until the once distant ASTP mission. I'm focusing on the period from July 3, 1974, to February 9, 1975. During this time, there would be 3 final test flights. No time left for more. Just 3 final steps remaining. Could they break the ongoing chain of dramatic emergencies? Sadly, no. These are the last 3 steps. 8th step. I called it, the commander took off his gloves. The story is told by spacecraft commander and cosmonaut Pavel Popovich. By the way, he was Ukrainian. Back then, it was all one country, and we achieved results together. Communication with mission control has ended, but we had to dock. To better feel the control sticks, I took off my spacesuit gloves. That's extremely dangerous. They were in pressurized spacesuits. Removing the gloves means depressurizing the suit. Europe protested. That was flight engineer Yuri Artukin. If we crash and the cabin depressurizes, nothing will save you. You'll survive and say I did it voluntarily. I re-established attitude sensing and hid dead center of the docking port. In other words, he docked perfectly, center of the target with minimal impact. How did they re-enter after such a minimal impact? Safely. In fact, it would be one of the few missions with a successful re-entry after docking. But was the mission itself trouble-free? Was the docking entirely safe? Can we trust cosmonauts on a joint mission to depressurize their suits and go ahead with docking? We cannot. If depressurization had occurred, the commander would have died within a dozen seconds. And there's no guarantee the flight engineer, who wasn't a pilot, could have returned the damaged spacecraft to Earth. Ninth step. The IGLA needle system malfunctioned. IGLA is the automatic rendezvous system used for spacecraft. After an initial approach, when the distance is down to hundreds of meters, cosmonauts often switch to manual control. But at a distance of several kilometers, the system works automatically. Sometimes automation handles close approaches too. This happened in August 1974. IGLA malfunctioned, and the spacecraft rushed toward the station at a speed of 20 meters per second instead of the proper 30 centimeters per second. It shot past the orbital station just 40 meters away. 40 meters might sound like plenty of space to us regular folks, but the station is 15 to 16 meters in size, and the spacecraft is about 7 meters. That's tight. A slight drift left or right, and you've got a collision. There were actual minor collisions later. Soft ones, but still. The spacecraft then made 2 more dangerously close passes, darting around the station, back and forth. The automatic system kept pushing it until ground control finally shut IGLA down. By then, they didn't have enough fuel for a manual docking. My addition, 20 meters per second. We're not birds. We don't fly, so we don't intuitively grasp that speed. But we all know 70 kilometers per hour by car. That's the same as 20 meters per second. Imagine a 7-ton truck, the spacecraft, slamming into a 20-ton semi, the station, at that speed. The outcome is obvious. The orange danger warning is obvious too. And finally, the 10th step. Once again, parachutes. Remember Komarov's first flight? Back then they said, well yes, the parachute failed. A tragedy. But in 8 years, all parachutes would be working. Not at all. It remained a vulnerable point. Cosmonaut Grechko's words. To die. That's a truly horrifying thing. On January 11, 1975, Soyuz 17 successfully docked with the station. They worked on the station for 29 days and began their return to Earth. What happened next is told by Grechko. Source linked below. At the appointed time, the parachute didn't open. Neither did the reserve. That meant we had 5 minutes left to live. 3 minutes. I'm quoting the text from the source. To die. That's a truly horrifying thing. Fortunately, the parachute finally deployed. And like a sail, it made the spacecraft bounce several times off the ground. Well, the descent speed was high, just 3 minutes to decelerate. When they were carrying us to the helicopter, I looked and saw there were deep craters in the frozen ground. Parachute descent lasts 15 minutes. Another 3 minutes, and they would have met the same fate as Komarov. That's it. The last 3 test flights are done, and all 3 were accompanied by dangerous incidents. No more test flights before the ASTP mission. In total, from October 1967 to February 1975, 10 test missions were carried out, 8 of them manned. Let's look at the statistics for the cosmonauts and the dangerous incidents where they could have been injured or killed. At the top, I always provide a green line. Remember the green table for solo flights? Same as here. If we exclude dockings, there were no serious incidents or dangers in solo missions. But with dockings, the incident stats for cosmonauts are as follows. Many cosmonauts flew more than once. For example, Shah Talib flew 3 times. So don't match the number of cosmonauts to the number of spacecraft. Out of 15 cosmonauts, 3 died. From Soyuz 11, Dobrovolsky, Volkov, Patsayev. 10 others were at the death's door. Volynov on Soyuz 5, the burning ship. Shah Talib, Yeliseyev, Rukavishnikov. Soyuz 10, trapped in orbit. Popovich, Artukin. Had to depressurize the spacesuit. Sarafanov, Demon. 3 extremely dangerous flybys near the station. Gubarev, Grechko. Had only 3 minutes to avoid a crash. Only 2 out of the 15 cosmonauts did not find themselves in a life-threatening situation. 13 out of 15. That's 90%. Spaceflight is always risky, but this wasn't just risk, this was inevitability. I'll repeat what I've said before. If you're going for a docking, you'd better be ready for an emergency. That's a completely unsuitable backdrop for an international joint mission. Now the stats for flights and spacecraft, not people. This is only about the spacecraft. Again, I forgot to mark the green line at the top. For solo missions, all completed successfully, no incidents. But for dockings, there were 9 incidents and 1 tragedy. Let me recap the incidents. Descent too steep, 9G. Descent too shallow, unpredictable landing site, spacecraft destroyed. Dragged several kilometers across the steppe. Soyuz 5 caught fire. Soyuz 10's probe malfunctioned, station wouldn't let go for 5 hours. Crew of Soyuz 11 died. Spacesuit depressurization, dangerous flybys of the station. Late parachute deployment, 7 missions involving 11 spacecraft. We now approach the conclusion of the first major section. A real international joint mission involving 2 spacecraft requires reliable and safe docking technology. However, up until the very launch of ASTP, successful docking didn't occur in every test flight, and 90% of the time, life-threatening incidents occurred, with 1 fatal mission. Such a poor record with docking technology ruled out a real joint mission like ASTP. Therefore, on July 15, 1975, instead of a real joint flight, a simulation of one was carried out.